Yes, it is, I suppose. But then I suppose if we wanted to represent that, I mean, at the decisive point it jumps, and then it becomes very high or something. But it's still, the best representation is still to say that it's steep, I think, at that point. If you have to make a linear kind of. Now this is the kind of situation when you want a quantity type instrument. This is a bit like the arsenic. So then you want a regulation which kind of keeps you away from the threshold. The optimum price might be here or something, but we don't want to take any risks. We want a regulation. In reality, there are a lot of other reasons also how, like political feasibility. And distributional, it gets enmeshed. And I think maybe a little wrongly, I think a lot of the debate about instruments is between taxes and permits, and I think that both politicians and media and everybody else mixes up these two dimensions, and they sort of say, oh, we prefer taxes because it gives revenue, or we prefer permits because industry finds them more acceptable or something, or well, we need, and then this gets mixed up with the Marty Weitzman kind of argument that you want a tax because it's the benefit curve is flat. So these are really two separate arguments. And you can choose a price type instrument and still give the rent to industry, for instance, by using subsidies, or by using these revenue neutral instruments that are combinations of a tax and a subsidy, which have just happened in Norway for NOx, and in Sweden, in fact. They're slightly different. And that can happen with permits too. You can give away the permits, we give away the permits partly, give away some of the permits, and the industry has to buy some. Then there are some mixed instruments. And what's a mixed instrument, in fact, can look pretty much like this curve. So there can be, there could be a tax. When you are down here, there could be a tax. If and then there could be a rule, you're not allowed to emit more than, there's a tax and there's a rule, you're not allowed to emit more. And if you emit more, there's a penalty tax up here, which is 5 times the normal tax. So this is the trouble with rules, they don't always get followed. So if they don't get followed, you have to have there has to be some kind of consequence, and that could be a fine, and the fine can be much higher than the tax. And so that's an instrument that's kind of has both price and quantity type. And you can do that with permits too. You can have a hand out one number of permits, and then you can say, oh, if the price would get too high, we will hand out some extra permits. That in fact, can you hear me? Nee. Yeah, so Fred Krupp, who is the president of EDF, he doesn't like taxes, precisely, because I want to know the number of I want to know the pollution level. That's the thing I want to decide. And for the same reason, he doesn't really like the idea of that there could be extra. And that's a nice environmental viewpoint. But then, of course, the counter argument is that suppose you're going to negotiate. There's a negotiation with industry. And we're talking about E. And so we are going to our instrument looks like this, right? Like a stick. And we're going to say this this stick will never move, right? This is an instrument, it is the arm of the law, you know, and we will put out the whole police and the army and whatever, and it will never move, because this is our environment, right? This is very important. So if you have an instrument that looks like that, then industry is going to say, well, for God's sake, you know, we think we might be selling gazillions of tons of cement to China in the future, and we could be making a pile of money, and we will need a lot of permits. So don't put it there, you know, put it over here, because we might need those permits. Otherwise, the demand for permits will be very high. The price might get, very high, and everybody will complain. And if you tell me we can never move this thing once we put it there, we think there's going to be 8% growth. You know, yeah. So we maybe we should really have it out here, but okay, and put it here as a compromise. Yeah. So then it can be useful to say our instrument actually does not look like that. Our instrument looks like this, and like, oh, if the price gets really high, there'll be an extra allocation. If our instrument looks like that, it's easier to put it over here. So it can affect, like the rules for the changing of an agreement can affect where you get the first agreement, the negotiation. So that's it's not like, I'm a green guy, so it's not that like I like the idea that there would be extra permits. But I like it because it would be easier to move the first agreement in this direction. So it's all about, basically, it comes back all the time to Marty Weitzman's idea. We don't know where the abatement and the benefit curves are going to be, and there's risk about this, and there's asymmetric risk about it, and so it's a matter of what you believe about which curve is worse, which is steeper. It's actually a very fundamental idea. So it's an article. I haven't said that very many times, but that is an article really is worth reading several times and thinking about. So, we're going to think about time as well today. I'm going to hand out the exercise. And there's a seminar at 12. So we don't want to kind of crash into 12, and we want to have a break there, I think. But we'll start at 10 past 12. Still. So, there's a lot of other aspects to policy making, and this choice between P and Q and between who should get the permits is just modified by a lot of other arguments about lobbying and political scientists. They will often, economists will be focused on which instruments. Political scientists will be focused on the process. They don't have quite so strong an opinion about the instruments, but they say, like, who should we invite to the meeting? And how long should the meeting be? And who should be the chairman of the meeting? And what's the follow-up to the meeting? And the process of making the decision. And then basically, the stakeholders will sort of come to some agreement. So it's a very different approach. A lot of subsidies, I don't know, Sweden, it's a small country, we still spend so many billions on subsidies. The state had a program for subsidies to municipalities, for instance, and to companies. There's the psychology of incentives that crowd out. Sometimes economic incentives can crowd out moral arguments. We talked about that. There's the whole issue of monitoring, and this is Winston Harrington, also an economist at RFF. It's nice to have a paradox named after you. So I don't know, I have to think of something for the Stirner paradox. But Winston, his paradox is that there's so many rules environmental rules. And the paradox is that companies follow them. There isn't actually a lot of enforcement and monitoring. But still, most companies actually follow. So the paradox is why? And that's the kind of thing that graduate students write articles about and postdocs. And so you find some industry somewhere that are following the rule or the law or are not, and then you try to find why is the Harrington paradox? Well, we had one of my grad students here wrote a paper like that, and we kind of got Winston to comment on it. He's a nice guy. Yeah. There's always this question about corruption. It's like the whole, illegal economy, all this is very hard to get data on. And the same thing with corruption. You can't really ask people if they're corrupt. We try to get around this in surveys by asking, do you think your colleagues are corrupt? That kind of thing, but it's only halfway getting around the problem. Yeah, we talked about trichloroethylene. I won't say anything about that. We talked about nitrous oxides, how they have different instruments. The United States is still they're somewhere between, they have used grandfathering and benchmarking to appease industry. In Sweden we use refunded emission payments. In Norway they had this tax subsidy. The refunded emission payment, I think the most important thing is that it splits the industry lobby and makes it possible to have a really high tax or fee level. For cars, we have chosen another instrument. Why don't we have refunded emission payments for nitrogen oxide from cars? Yeah, because it would be difficult to measure the nitrogen oxides from all the cars. A perfect instrument, you'd have a measurement of exactly what is coming out of the exhaust. And there'd be a GPS on every car, and you would pay the real damage you're causing. And if you're emitting a lot of nitrogen oxides in the center of an important town with rich people, you would be paying more, right, than if you are emitting less and in the countryside where there's few people around. But that's too complicated. So instead we just have a rule. You have to have a catalytic converter. And the great thing about that is that it creates a market of a few billion catalytic converters so that industry and chemists can focus on like one technology and they can optimize the catalytic converter. So now we have really good catalytic converters. They are cheap and they work well. So this is, I think I showed this diagram, but I'm going to talk a little bit more about it. It's kind of tied to the exercise here. This is, we're now preparing, right, two polluters emitting 20 tons each. And the marginal costs are for company 1, MC1 is equal to A1. So that means that each ton of abatement, the first ton cost 1, the second 2, and the third, and so on. And the last one cost 20. And so this is a 45 degrees, just I haven't, the scale is, just so I can squeeze in the other one, which has a marginal cost of 4A, marginal cost 2. So now if I ask them each to do abatement of 10 units, then the cost will be this triangle, the small triangle plus the big triangle, right? Which I have on the next page. So this is a yellow triangle here. It just looks green because it's also part of the blue triangle, right? And the areas are kind of easy. What's the size of this triangle here? This is MC1 equals A1, so this is 10 here. It's 10 times 10 divided by 2 is 50, right? And the other one is going to be 200. So the total cost of that arrangement is 250. And now along comes the economist and says, hey, why don't we let them trade? Or why don't we impose a tax? And because we've done our math before, we know that the marginal cost that equalizes things here is going to be 16. If we have a tax of 16, then this guy will do 4 units of abatement, and this one will do 16. If it was tradable permits, and they got 10 permits each, then company 2 will buy 6 units from company 1. And the equilibrium price will again be 16, assuming that they are behaving like it was a competitive market. There's no market power on the permit market and so on. And then the cost of that is this triangle here. What do you got it here? This triangle plus this triangle. And what's that? What's the size of this triangle? Well, it has a base of 4 and a height of 16. So it's 32, right? And the other one, where is it here, has a base of 16 and a height of 16. 16 times 16 is 256, divided by 2 is 128. So that equals 160. And I did this all on purpose quickly just to show how simple it is. But we actually saved $90 million there in 10 minutes. If you're a consultant and you get 25% of the cost savings, that's great business. So that's why we want to be environmental economists, right? We can save money here. The environment will be equally clean, and we save lots of money. And again, the trick to do, where is that one here? The trick for calculating this is as triangles. I mean, it looks a bit messy, but this is extremely simple, right? Now the interesting thing is, though, let's go back to this one here, that if you're the Environmental Protection Agency, this company is kind of your friend. No, this one is your friend, right? They do lots of abatement. They really help you, so instead of just doing this area, they do all this abatement, and then the other one, which has all this very expensive abatement, they don't have to do so much. The trouble is, what are you doing to your friends? You work for the EPA or the Chemical Inspectorate or something. You like this company, but they actually end up doing more abatement. The bad guys end up doing less. And so the same thing happens with, trichloroethylene, for instance, which was not a tax, it was a ban. But still, some of the progressive companies, they made up new inventions, and they had boiling water with lemon peel in it, and they had lots of costs and trouble. And some of the really bad guys who just wanted to continue with trichloroethylene, they got an exemption. And they could go on with that trichloroethylene, and of course it was not good for the workers, but it might have been good for profits, because they made no effort, and they were rewarded by being kind of let off the hook. It's a little bit the same here. The guy who says his abatement is so expensive, we don't really know if these curves are true or not. He says it's so hard to abate in his factory, so then we say, okay, well, don't abate so much then. So that's kind of somehow unreasonable. And the interesting thing is then, we need to think about the instruments. And if you look at a tax here, the nice thing about the tax is that the company that does a lot of abatement only has to pay a small tax, because they abate 16, so they only emit 4. they pay the tax on the 4. And the company which does a little abatement, they have to pay really big tax. So the instrument costs help in correcting an unfairness that seems to be there in the abatement, the amount of abatement you do. And it's the same thing with permit trade. If they are given 10 permits each, then this company has to buy these permits, and this company gets to sell these permits, where they do extra abatement. So again, the sort of the trade in permits, and that's what I calculate here, because here you have the abatement costs. This is the area under those triangles. H is the heterogeneity. It's the number 4 that I have here. It's the difference between the high polluting abatement cost companies and the low ones. And then you work out the permit cost and the total cost, and you see that with the instrument, whether the instrument helps correct or maybe overcompensate, and which companies. So this is, like the first hour I talked about who pays, whether it's society or the victims of pollution or the polluters. Here we're talking about different polluters. So there's a level of distribution there that is a finer level of distribution. And that's what this exercise is going to be about. There is, can you find this in there? There's a table. Yes, it's a table on table 9.1, on page 146. It shows like how important all this is depending on the size of H. H is the difference between these curves. And it turns out, I was surprised when I made this table. Maybe I should try to publish that actually as an article. I think it's an interesting point, right? Because if the difference between the two curves is just 50%, so that you have the first curve is here and the second curve is like there, 50, well, that was less than 50%, but suppose it was 50%, then the benefit of using market-based instruments compared to using regulation is just 4%. And like 4%, well, 4% of a million is 40,000, but like, who cares? This is kind of within the margin of error. It's too small. If the difference is 100, I mean, if one company has a marginal abatement cost curve down here, and the other one is up in, in the sky, then the principle of the market is very important. You can save 96% of the costs by using, so it's basically, when do you want to call an economist? Well, when the costs of abatement are very heterogeneous. That's when you need an economist. If they're all kind of similar, you might as well just use an linear, tell everybody to cut their abatement in half. It's a simple rule, and you don't need the economists. You don't need the market principle. So then the next question is, what is H? How heterogeneous are the abatement costs in climate change? Well, I don't know. It's just I can say that the difference between methane emissions from cows in India and driving cars in New York, there's no reason to believe that the marginal abatement costs should be similar. They could be very different. And if they're very different, the market principle will save you a lot of money. So I think that's a sort of an important point. Again, it only works if they're linear. If they're not linear, then the algebra would get extremely complicated.
Yeah, but the point would be the same.
Yeah, same point. Yeah, indeed. Let me just tell you a little bit about the policy instrument exercise. So we're going to form groups. How many are we? Okay, about 20. So we'll have 7 groups, 3 in each then, basically. Well, there will be 2 in some group. Just 1 or 2 groups with 2. It should say 2014 there. So there's a ministry. I'm the minister. And we've decided to cut emissions. This is going to be for the paper industry. There's biological waste that's destroying the rivers. And the ministry has decided we're going to cut emissions by 50%. Our eminent chief economist has decided that a tax of $40 per ton would do the trick. So that's the marginal cost at the optimum. And you are the board members of 6 different companies. And you can see, read my lips, this is a serious problem. We are going to deal with this. But I'm prepared to listen to you about which instrument we'll choose. So you will have to think about this in your board and then come up with, advice or comments on which instrument you would like us to choose. And you should think at least about this list of instruments. Like, we really think, my engineers in the ministry, they say that the simplest thing would just be to tell everybody to abate 25 tons, because then we know there'll be 150 tons of abatement. That seems fair. Everybody gets 25 tons of abatement. So there could also be equal percentage reductions, of course. That would, so some kind of equal, there's 2 equal kind of principles there, either equal tons or equal percent. There could be a tax. That would give a little revenue, so I would be pleased with that as a minister. There could be auction permits, there could be a subsidy. Well, we don't really have much money, so I don't know about the subsidy, but there could be a refunded emission payment scheme, there could be permit trading. We could we'll see how we hand out the permits, but that could be open for some discussion. I don't even want to talk about the other instrument, but that's something you might want to suggest. And the exercise is really simple. Here is all the data you need. And when it says 2012, it should say 2014. So that's like the current emissions, and your output, and your abatement cost functions. So now you just have to calculate a lot of triangles and rectangles and work out what the different instruments would imply in costs for your company. You might want to check what the competitors, Sometimes you might want to take a small cost, and if your competitors get an even bigger cost, that might be quite good for you. So you need to calculate what would be best for you. And then kind of, come up with, people have tried sometimes using other programs, but I think Excel is the easiest way of calculating this. And I think it's worth your time to design a nice spreadsheet, because it's basically the same calculation 100 times. So you just do a nice layout, then it's quite easy to change the assumptions and quickly calculate everything for all the companies and different instruments and stuff. And then you prepare a briefing. Eventually we'll have a meeting where you'll all come. And that was actually the inspiration for this. I was at a special seminar once at RFF. And I was told it's a special seminar, but we're inviting you. But it's only by invitation, so you can't bring any of your friends. So I went to the seminar. It was about nitrogen oxides. And I was kind of given 10 minutes to present the Swedish refunded emission payments. And then there were lots of colleagues of mine, but they were all wearing suits, and they were all arguing very strongly for one or the other instrument. At first I thought it was a little strange, and then I realized I was the only guy in there who was not being paid by someone. All my colleagues and friends were being paid by some power company. That's why they were such a strong opinions. Well, this is the best instrument. Permit should be based on, on emissions in 1991 and whatever. And with all these, they were very persuasive, very fast-talking Americans, and so they all sounded like they had the best solution. But it was probably the solution that was best for the company that was paying them, I think, basically. It's fascinating day. So that's the exercise. And we need to divide you up in groups. That would be 6 groups, but then there's also one group, M, for ministry. So that would be my they would be working with me in the ministry. They would do the similar calculation, but kind of from the perspective of the ministry, and see what the government should recommend in the end, and